On September 10, 2025, NASA announced that its Perseverance rover had found what it called a potential biosignature on Mars, a rock sample collected from the Bright Angel Formation inside. Jezero Crater contained chemical patterns that may have been left by microbial life billions of years ago. The results were published in Nature, and NASA declared it the closest we have ever come to discovering life on Mars. The key evidence was a set of strange markings on a reddish rock that the team named Leopard spots. Dark dots encircled by pale white rings were scattered across the stone in patterns, strikingly similar to those left by microbial colonies in Earth's wetlands and seafloor sediments. On our planet, this mineral arrangement is a recognized fingerprint of microbial metabolism in sedimentary environments. But whether the spots represent ancient biological activity or merely sterile chemistry cannot be confirmed by a rover alone. The sample must be returned to Earth for definitive laboratory analysis. Yet the mission built to accomplish that very task has been effectively killed. Was Mars once a living world, and will we ever know? Jezero Crater sits near the Martian equator on the edge of the Acidus Basin, stretching roughly 45 kilometers across. About 3.5 billion years ago, this barren pit was a deep lake, a river some 400 meters wide, now called Neretva Vallis, carved through the northwestern rim and poured water and sediment into the basin. Where water met the lake, debris fanned into a broad delta, formed by the same process that built the Nile Delta on Earth. Such deltas concentrate organic matter, minerals, and chemical energy in one place, creating ideal conditions for microbes that live off reactions between sediment and water. This is why NASA picked Jezero over 60 other candidates as the landing site for Perseverance. If Mars ever hosted even a brief pulse of microbial life, scientists expected its best preserved traces to lie here. The rover touched down on the crater floor on February 18, 2021, and has since driven more than 40 kilometers, drilling and sealing 27 rock cores into titanium tubes. In July 2024, it rolled up to a rock that would reshape the search for life beyond Earth. The rock was named Cheyava Falls after an Arizona waterfall. Shaped like an arrowhead, it measured about 1 meter wide and sat within the Bright Angel Formation. That lines the ancient Neretva Vallis channel. Perseverance drilled a thin core. The team called Sapphire Canyon and aimed 2 instruments at the surface. PIXL, an X-ray scanner, mapped elements at micrometer scale, while SHERLOC, a Raman spectrometer, hunted for organic molecules. What they found halted the science team in its tracks. Across the red surface lay clusters of dark spots, each ringed in white, echoing a leopard's coat. The dark centers held Greigite, an iron sulfide mineral, and the white halos were rich in Vivianite, a hydrated iron phosphate. On Earth, Vivianite turns up in peat bogs and waterlogged sediments, near decaying organic matter. Greigite can be made by anaerobic microbes that strip electrons from sulfate to power their metabolism, finding both in concentric rings inside. A single rock points to electron transfer reactions between sediment and organic material, the exact chemical process that earthly microbes use to fuel growth. The rock was also packed with organic carbon, sulfur, and phosphorus, all raw ingredients for life. Here the story turns sharply. Vivianite and Greigite can form without life if temperatures run high enough, if strongly acidic fluids mobilize iron, or if certain organic molecules act as catalysts. The same minerals can crystallize through abiotic chemistry alone. So leopard spots do not automatically prove that Mars once harbored living organisms. The Nature paper, however, tested each non-biological scenario and offered strong pushback. First, the Bright Angel rocks are fine. Clay and silt with no trace of high heat or hydrothermal alteration. Second, their chemistry is inconsistent with strongly acidic conditions. Third, no one has demonstrated that the organic compounds present could drive this reaction at Mars-like low temperatures without biological help. Lead author Joel Hurowitz of Stony Brook University cautioned that compelling chemical signatures do not equal confirmed biosignatures, saying the team still needed to understand what the data could mean. The paper concluded that abiotic explanations fit the evidence less well, yet stopped short of declaring a biological origin. Science has cracked open a door but has not stepped through. The gap between a tantalizing hint and a proven discovery remains as wide as the Martian horizon. Buried inside this discovery, is another mystery that has electrified researchers. Bright Angel belongs to a relatively young layer among the sedimentary rocks Perseverance has studied. Scientists had long assumed that any trace of ancient life would appear in the oldest strata, dating past 4 billion years, when Mars was warmest and wettest. Finding a potential biosignature in younger rock implies that the planet stayed habitable, far longer or far later than anyone expected. A follow-up study published in January 2026 added weight to that idea. Researchers found kaolinite pebbles inside Jezero Crater. Kaolinite is a clay mineral that on Earth forms only under warm, humid weathering. Its presence suggests ancient Mars was not merely cold and dry, but may have sustained a mild, wet climate for extended stretches. If every clue points the same way, then 3.5 billion years ago, Mars had flowing rivers, organic-rich deltas, and enough chemical energy to support microbial ecosystems. Verifying that extraordinary story, however, requires one critical step, and that step has just hit a devastating wall. Settling the question demands tools no rover can carry: electron microscopes, isotope mass spectrometers, and nanoscale organic structure imagers, thousands of times more powerful than anything on Mars. NASA and the European Space Agency spent years designing the Mars Sample Return mission to retrieve the tubes, launch them into orbit, and ferry them back to Earth. It was among the most ambitious robotic endeavors ever planned. Then an independent review board pegged the projected cost at roughly $10.9 billion, and congressional resistance surged. In January 2026, lawmakers passed a spending bill that zeroed out all MSR funding, effectively canceling the program. The 27 titanium tubes Perseverance deposited across the surface now sit in indefinite limbo, waiting for a ride that may never arrive. China, meanwhile, is pressing ahead with Tianwen-3, aiming to scoop up Martian material and return it to Earth by around 2028. If Beijing succeeds, it will claim the historic first in Mars sample return. The secret locked inside those leopard spots is no longer just a scientific puzzle. It has become a contest of budgets, politics, and global ambition. Sapphire Canyon is a rock core, just centimeters across and about 6 centimeters long, small enough to hold between 2 fingers. Yet it may carry the answer to one of humanity's oldest questions. Did life ever arise beyond Earth? The concentric Vivianite Greigite pattern inside. The leopard spots mirrors the chemical traces that microbial colonies stamp into wetland and seafloor sediments on our own planet. Non-biological pathways struggle to account for the pattern, given the data in hand, but the limits of rover-based analysis mean biology cannot be confirmed outright. The only road to certainty leads through a terrestrial laboratory, and that road is now blocked by budget cuts. 27 sealed titanium tubes lie scattered across the Martian dust, silent witnesses to one of the most tantalizing findings in planetary science. They pose an uncomfortable question: does humanity truly want the answer? And are we prepared for what it might mean? If the leopard spots are genuine traces of ancient microbes, we may already hold proof that we are not alone in the cosmos. We simply have not unsealed the evidence. Mars has guarded this secret for 3.5 billion years. Will we ever hear its reply?